St Elmo's fire is a luminous, electrical discharge that appears as a bright, often bluish or violet glow, often seen around pointed objects like ship masts, airplane wings, or lightning rods during thunderstorms. It occurs when a strong electric field ionizes the air, creating a plasma around the object. While visually striking, it is a sign of intense electrical activity and can precede or accompany lightning strikes. Here's a more detailed explanation. Formation. St Elmo's fire forms when a highly charged electrical field exists in the atmosphere, typically during thunderstorms. Process. The strong electric field ionizes the air molecules around pointed objects, like the mast of a ship or the wing of an airplane, turning them into a plasma. Appearance. This plasma emits a visible glow, often bluish or violet in color, and can be accompanied by a crackling or hissing sound. Significance. While not directly dangerous, St. Elmo's fire indicates the presence of a strong electrical field, which can be a precursor to lightning strikes. Historical context. Sailors, who often observed this phenomenon during storms, named it after Saint Erasmus of Formia, the patron saint of sailors. St Elmo's fire is a weather phenomenon where a corona discharge creates a luminous plasma, often seen as a blue or violet glow, around pointed objects during thunderstorms. It occurs when a strong electric field ionizes the air molecules around the object, causing them to emit light as they return to a lower energy state. 1. High electrical voltage. St Elmo's fire requires a strong electric field, typically found during thunderstorms. 2. Charged objects. The phenomenon is most often observed on pointed objects like ship masts, aircraft wings, or tall structures. These objects concentrate the electric field around them. 3. Ionization. The intense electric field strips electrons from air molecules, creating plasma, ionized air. 4. Corona discharge. The plasma emits light as electrons recombine with ions, transitioning to lower energy states. 5. Color. The color of the glow, blue, violet, or even green, depends on the type of gas involved in the ionization. In Earth's atmosphere, it's primarily nitrogen and oxygen, leading to blue or violet hues. 6. Sound. The ionization process can also produce a hissing or buzzing sound. St Elmo's fire is a relatively rare weather phenomenon, characterized by a luminous, often blue or violet glow, that appears on pointed objects like ship masts, airplane wings, or lightning rods during thunderstorms. It's not actual fire, but rather a type of electrical discharge caused by a strong electric field. While it can be striking and even mesmerizing, it's not extremely common to witness. Here's why it's rare and what it looks like. Rare event. St Elmo's fire requires specific atmospheric conditions, including a strong electrical field and pointed objects for the discharge to occur. Visible in low light. The glow is most noticeable in low light conditions, like during a thunderstorm at night. Electrical discharge. Instead of a direct flow of electrons like lightning, St Elmo's fire is a more localized and less intense electrical discharge. Not dangerous, but a warning. While not directly dangerous, it indicates a high-voltage electric field and suggests the possibility of nearby lightning strikes, according to the National Weather Service. Name origin. It gets its name from Saint Erasmus of Formia, the patron saint of sailors, as it was often seen on ships during storms. Not ball lightning. It's important to distinguish St Elmo's fire from ball lightning, which is a separate and even rarer phenomenon. St Elmo's fire can appear in different colors, though it's most commonly associated with blue or violet hues. The specific color depends on the type of gas involved in the electrical discharge. Here's a breakdown. Blue/violet. This is the most frequently observed color of St Elmo's fire, due to the presence of nitrogen and oxygen in the Earth's atmosphere, which glow when ionized, according to Wikipedia. Red/orange. Neon gas, when ionized, produces a reddish or orange glow, which can be seen in some instances of St Elmo's fire. Green, while less common, St Elmo's fire can also exhibit a greenish tinge. The color variation is a result of the different gases becoming ionized and emitting light at specific wavelengths during the electrical discharge.